you can always divide sine by cosine. Sine divided by cosine is 0. Sine divided by cosine is 1 over root 3, but if you rationalize it, it's root 3 over 3. If you were to multiply both numerator and denominator by root 3 in order to get the denominator rational. That over that is 1. That over that is root 3. Because the 2's cancel out and then you end up with root 3 over 1, which is root 3. And tangent of 90, 1 over 0 is undefined. So these numbers may require memorization. They will. Now, I want to introduce you to the concept of the unit circle. Because sometimes they may ask you for the cosine of 120, and you'll say, you can't have a triangle with a right angle and also a 120-degree angle. But this is approaching things from a theoretical perspective and using sine and cosine for other things. Alright, here we have a circle. And to make things sort of standardized, we will say that the circle has a radius of 1. So no matter where you are on this circle, you're exactly 1 unit away from the origin, from the center. You'll notice I've graphed this on an x and y coordinate grid. It's a circle with radius 1. So this is 1, this is 1, this is negative 1, and this is negative 1. So this has uses. First of all, I want to explain it through the lens of physics. Let's say I throw a ball with a velocity of 1 meter per second, or 1 whatever, at a 15-degree upward angle. Well, it's traveling this way at 1 meter per second, 10 meters per second, whatever. The question is, how quickly is it moving up, and how quickly is it moving over if it's moving in that direction at 1 meter per second, or whatever. If we know it at 1, we can just sort of multiply everything by 10 for 10, or by 50 for 50. What's important is to know it for 1, and then we can modify it by multiplying everything from there. The idea is to know the ratios of things, like sine and cosine, not to know necessarily the exact amount yet. So, let's say I throw something with a speed of 1 meter per second at a 30-degree angle. Do I know how quickly it's moving up and how quickly it's moving over? Well, yes, because since up is at a right angle to over, I can use sine and cosine here. The opposite side is always half of the hypotenuse, so the opposite side will be 0.5. And over would be root 3 over 2, which you could calculate in your calculator. It's like 0.866 or something. So basically, let's say I throw something at a speed of 20 meters per second at a 30-degree angle upward. Now I know that its upward movement, did I say I'd throw it at 20? Yeah, I'm not stronger than 20. So 20 meters per second at a 30-degree angle means it'll be moving upwards at 10 meters a second, and it'll be moving forward at whatever this is times 20 meters per second. And so I can separate the movement of something into an upwards and forwards components and separate them and look at each one separately. Now I can do this at any angle. And this is why it is useful to consider a 0-degree angle in a right triangle. If I throw something at 0 degrees upwards, then what percentage of that momentum is forward momentum? 100%, 1. And what percentage of it is upward momentum? 0. Right? What percentage of that is upward momentum? 0%. If I throw something at a 45-degree angle, you'd think that you throw something at a 45-degree angle, you know, it moves at 20 meters per second that way, that means it moves 10 meters a second this way and 10 meters a second this way. But triangles don't work like that. 10 forward and 10 up doesn't mean that the hypotenuse is 20. Pythagoras says it'd be worth about 14. So what's really true is if I throw something at a 45-degree angle that way, with a velocity of 1, or with force of 1, if you're doing physics, whatever, you can do it all with physics, then you can figure out, oh, you know, what is the sine of a 45-degree angle? That'll find me the opposite's relationship to the hypotenuse. Well, it's root 2 over 2, so if this is 1, this is root 2 over 2. Same thing for this side, this is root 2 over 2, and that's about 0.7. So if for every 1 bit of force that I put into it on a diagonal, that's like putting 0.7 bits of force forward and 0.7 bits of force upwards. Those two would combine to create 1 in that sort of forward angle. And that is the idea of the unit circle. But it also means that we can do this, all right? So let's say I throw it at a 0-degree angle, at a 30-degree angle, at a 45-degree angle, at a 60-degree angle, at a 90-degree angle, at 120 degrees. Let's say I throw something in the direction of 120 degrees. How much upwards, how much forwards? Well, here's my right triangle. The amount of upwards is still very big. It's actually directly opposite the 60-degree angle, 120, because this is 90, so 30 less, 30 more, same thing. So the amount of upwards is root 3 over 2. And the amount of backwards, hey, this is a 30, look at this, this is a 30, 60, 90. Because if this is 120, that means this is 60. This is 90, this is 30. And oh look, this is 1/2. So if I throw something in 120-degree direction, it's got half of the strength it would if I had thrown it straight forward. And it's got root 3 over 2 of the upwards force as if it were thrown straight upwards. And that's how the unit circle is used. Now, what are the patterns like? Why? Like, you'll notice that it's, again, 1/2 and root 3 over 2, the same numbers for sine, cosine, and cosine as there were with degree angles of like 30 and 60 and 45. Well, that's because the numbers show up again, only this time some of them are negative because we're going backwards, or later on, down. They all follow, both sine and cosine follow this cycle. 0, 1 over 2, root 2 over 2, root 3 over 2. Oh, you know what? I need more space. They all follow this pattern. 0 over 2. Well, let me put this way. It's root 0 over 2. Root 1 over 2. Root 2 over 2. Root 3 over 2. Root 4 over 2. And then they come back down. Root 3 over 2. Root 2 over 2. Root 1 over 2. Wah, wah. Root 1 over 2. Root 0 over 2. So it's come all the way back down, right? It went up and then came back down and then it goes under and then comes back up. Negative root 1 over 2. Negative root 2 over 2. Negative root 3 over 2. Negative root 4 over 2. Negative root 3 over 2. And so forth. Now, I haven't simplified these at all. Also, you'll notice there's 4 steps on the way up. 0, 30, 45, 60, 90. So starting at 0, then you have 1, 2, 3, 4 steps up. 1, 2, 3, 4 steps up. And similarly, you can have 1, 2, 3, 4 steps down. 30 below, 45 below, 60 below, 90 below. Now I haven't written these in simplified form. Root 0 is of course 0, and 0 divided by 2 is 0. Root 1 over 2 is the same as regular 1 over 2. Root 2 over 2 can't be simplified. Root 3 over 2 can't be simplified. Root 4 is 2. 2 divided by 2 is 1. And then we come back down. Root 3 over 2, root 2 over 2, 1/2, 0, and then we head into the negatives and we come back up. It's this cycle, and the only difference is where we start. Sine, which always starts off considering the opposite side, starts small and grows and grows and grows, and then shrinks and shrinks and shrinks because the opposite side gets small again. Sine represents the vertical component, how much up. When we start at 0 degrees, it starts at 0, and then rises and then falls, and then rises and then falls, and then goes under and comes back up. Cosine is different. Cosine represents the adjacent compared to the hypotenuse. At the very beginning, the adjacent side is basically 1. So cosine starts at 1, and it goes down and down and up and up. The amount of forward momentum is what cosine represents. It starts at 1, and then there's less forward momentum, and less forward momentum, and less forward momentum, and 0 forward momentum. Negative forward momentum, more negative forward momentum, more negative forward momentum, -1, full negative momentum. And then comes back up. It's just as if you turned your head 90 degrees, and it'd be the same as sine. Instead of starting off at 0, it starts off at 1 and goes from there. So yeah, sine and cosine, you have to start memorizing the values. And I'm going to throw one more wrench into your plans. And that is, say that we won't always measure angles in degrees. See, degrees are a stupid thing to actually measure angles by. Why are there 360 of these little amounts of turning in one full circle? I don't know, probably because the year has about 360 days in it. And dividing by 6 is nice, and being able to divide by 4 is nice. We like things that can be divided by all sorts of stuff. But people came up eventually with a different way of measuring the distance around the circle. They said, how many radiuses around the circle have you gone? Well, how many radiuses are there to go around the circle? The entire circumference of a circle is 2 times pi times r. This you probably learned in middle school. If you took the radius and stretched a whole bunch of them around the circle one by one, it would take a little bit more than 6 of them to go all the way around. And so people started measuring angles in what are called radians. Number of radiuses stretched around that I have gone around the circle. So let's say, what would have happened if I have gone around the circle exactly 1 radius? Well, that'll take me to about 60 degrees. It's more like 57 degrees. That's how far around the circle I've gotten. So they would say, instead of saying, what is the sine of 57.1 degrees, they would say, what is the sine of pi degrees? Or pi, what is the sine of, 1 radian? And so your calculators, if they're giving you the wrong answers for these, it may be because they're in the wrong setting. They may be set to calculate in radians instead of degrees. So you might note that button. There's a mode somewhere that'll change it from one to the other. What this means is to go around the entire circle means you have traveled 2 pi radians. So angles will start being measured in radians. 2 pi of them is the same as 360 degrees, which means that pi of them is exactly 180 degrees. So someone may ask you, what is the sine, what is the ratio between the opposite and the hypotenuse sides in a triangle where we have traveled 1/3 of a pi around the circle? Well, we haven't traveled 3 radians, well, we haven't traveled 3.14 radians, we've traveled about 1/3 of that, about 1 radian around the circle. Or if you prefer, since pi is 180 degrees, they're asking for the sine of 60 degrees, if they ask for the sine of pi over 3. And basically you need to be able to translate between any radian and any degree. If they tell you a number of degrees, 30 degrees, you have to be able to say, okay, but let's translate that into radians. I'll divide that by 180, and that tells me that I have a 1/6 of pi radians, more often written as pi over 6. Pi over 6 would be 30 degrees. Pi over 6 radians, 30 degrees. So there might be converting between radians and degrees that you have to do at some points during this. Beyond this, it's practice and memorization of those values of sine and cosine and which one is which. Practice time.